Hi everyone, it is Chapter 8, Origin of the Solar System and Extrasolar Planets. I am looking forward to this and I had a lot of fun putting this together, so let's get to it. When we talk about the origin of the solar system, we have to talk about what has changed in our solar system in the past few years even. And so we're going to take an overview of what we know about the solar system now, and then we're going to learn about new things like space degree and how we age the solar system. And then we're going to put all our observations together into a hypothesis or a theory for how the solar system may have originated. Of course, no one knows, no one was there. And then we're going to test those theories against solar systems that we can see now developing. So let's go for it. What we know. We've gone over the fact that we have terrestrial planets in the solar system. Those include Mercury, Venus, Earth, and Mars. And we have Jovian planets in the system. Remember, Jovi is Latin for Jupiter. And these are the gas giants or liquid giants. And they are Jupiter, Saturn, Uranus, and Neptune. There are big differences between these two planets. And of course, one of them is the distance from the sun. The terrestrial are much closer to the sun. The Jovian are much farther away. And then the other really big one is that the masses are quite different. The terrestrial masses are quite small. The Jovian masses are huge. And along with that, the terrestrial diameters are quite small. Jovian diameters are huge. Terrestrial, as in terra, are predominantly rocky. Jovian are predominantly gaseous and liquid. And I guess we'll say this too, that the terrestrial have slower rotations, so less gravity. And the Jovian have faster rotations, so higher gravity, because you're moving around that conductive material, causing an electrical field that's in turn causing a magnetic field. All right. Another big thing, no rings in the terrestrial area, in the terrestrial planets, many rings. In the Jovian planets, that was just determined in the 1990s because we never knew that Jupiter, Neptune, and Uranus had rings before the probes went out to see it, like Voyager. And the terrestrial planets tend to have fewer moons. The Jovian planets have many, many moons. In fact, their moons actually shepherd their rings and keep their rings in line. So that's what we know about terrestrial and Jovian planets. If you're like me, I grew up learning about Pluto as the 9th planet. And in 2006, that ended. So you've had a bit of that. You probably had that in kindergarten, where you might have learned about Pluto as the 9th planet. But let's take a look at why Pluto never fit in. It was always the odd man out. Not only was it not needed to counterbalance the perceived irregularities in the orbit of Neptune and Uranus, but it was not Jovian at all. It is not a gaseous or liquid planet. It has no rings, and it is not on the ecliptic plane. And you remember that we've talked about the ecliptic plane for the planets on their orbit around the sun. They all seem to be within about 6 degrees of each other, going in a counterclockwise direction with the exception of Venus. And Pluto is nowhere near that ecliptic. And I hope that you've seen the ecliptic across the sky when you've looked at Jupiter, Saturn, and Mars. And you can see them on a beautiful line in the sky. The Earth fits into that plane. That's the ecliptic. Pluto is nowhere near the ecliptic. And you see here that Pluto comes up and goes down, and it's not on the ecliptic at all. Not only that, but Pluto has a very elliptical orbit. In other words, it's more of an oval than the other orbits of the other 8 planets, which are more circular, a little bit off from that. but Pluto is way off from that. It also has a very strange axis rotation. All of the other planets, with the exception of Uranus, have their axes in a basically a north-south direction, and Pluto is very strange. Granted, Uranus is strange too, but there was a strange axis rotation for Pluto. It has a slower rotation. So Pluto actually rotates in every 6.5 days. Compare that to Jupiter. Huge Jupiter rotates and makes a rotational complete in 9.5 hours. It's astoundingly fast. So the other part that makes Pluto so strange is that for some times in its orbit, Pluto is closer to the sun than Neptune. So Pluto never fit in. It was always the odd man out. And in fact, when we look at Pluto now in the 1990s, we begin to see that Pluto doesn't match the definition of a planet by the International Astronomical Association. And that definition says to be a planet, a celestial body has to orbit our sun, and it has to pull itself into a spherical shape with its gravity. And with its gravity, it has to be able to clear out its orbit of other remnants and debris. For instance, it'll probably collide slowly with that debris and take it on. And over billions of years, it will shape that debris into its sphere. Pluto, on the other hand, can orbit the sun. Yes, it does. And it can pull itself into a spherical shape, but it is in the midst of a garbage field. And that garbage field is called the Kuiper Belt. That Kuiper Belt was really seen only in the 1990s, and it was predicted in the 1950s as being an icy, basically garbage dump of planetary debris, but it wasn't seen until the 1990s. Now we have about 1,200 objects that are called Kuiper Belt objects that are found in the Kuiper Belt. So Pluto is not considered a planet because it doesn't have the characteristics of the terrestrial or the Jovian planets, and it wasn't able to sweep out that very very crowded Kuiper field along its orbit and sweep out the debris. So it was in 2006 it was demoted by the International Astronomical Association. It was demoted to dwarf planet, which was a completely new definition at the time. Since then, we have all kinds of objects that are known as Kuiper Belt objects. You might hear them as KBOs, and they are also called Plutoids. And here are some of them here. And in many of them, they are caught in a 3-to-2 resonance with Neptune. Let's go over what a resonance is. A resonance means that two bodies that are orbiting effectively each other influence each other with their gravity. That's why they're orbiting each other. I'll go over it in a second. But in orbiting around each other, they stabilize each other's orbits so that in this resonance, you can put integers to this resonance. In this case, Neptune orbits the sun twice for every 3 times Pluto orbits the sun. It is specifically timed that way. And that integer difference stabilizes the orbit of both planets. Let's go over it. If we looked at Neptune in blue and we looked at Pluto in red and we started at 0, you see up here in blue the 0 where Neptune is. This is the sun. You see up here the 0, this is Neptune. they start in the same place. Let's just say they do. Let's go to 1. By the time we're at 1, Pluto is about 1/3 of the way around its orbit. But look at this. Neptune is 1/2 of the way around its orbit around the sun. By the time we get to 2, Neptune is all the way around its orbit around the sun, but Pluto is only 2/3 of the way around its orbit around the sun. So you can see now, by looking into this, that when you get to 3, Pluto made its first orbit. But guess what? When you get to 3, Neptune is already at 1.5 orbits. When you get to 4, Neptune is done with its 2 orbits. And when you get to 4 here, Pluto is at 1 1/3 orbits. So you can see how this is going to go. When you're at 6, Neptune has completed 3 orbits, and when you're at 6, Pluto has concluded 2 orbits. It's called a 3-to-2 resonance. It is the 3 is what is closest to the sun for the most part, Neptune. 2 is for what's farther away from the sun, for the most part, Pluto. They both profoundly impact each other's gravitational stability. Now, why does Neptune need stability? Very good question. And it goes back to a theory that I'm going to move this over so you can feel better about this theory. This is a theory of planet migration that said that Neptune was a little insecure in its orbit. Here's the theory. The theory is that the gas giants formed first out of a gas nebula cloud. And that if you look at the sun as being over here, and this is year 0 in the formation of our solar system about 4.5 billion years ago, you would have the sun over here, and you would have these gas giants, Jupiter, Saturn, Uranus, and Neptune in that order. And the theory is that there was what's called a grand tack. Not sure if you're any sailors here, but sailors tack into the wind and tack away from the wind. In the same way, Jupiter was pulled into the sun before the sun lit. This is a theory. Before the sun really got hot and lit, was pulled into the sun by the gravity of the sun. So Jupiter approached the sun and dragged Saturn with it and smushed all the rocky debris of the terrestrial planets. Then the sun lit, sent out enormous amounts of radiation and radiation particles and waves that produced a pressure, a solar wind, that effectively blew Jupiter back out. Here's the migration back out again. When Jupiter moved back out, everything started to push into the outer atmosphere, and Neptune got pushed quite a ways out. That's destabilized Neptune's orbit. And the thought is that in destabilizing Neptune's orbit, that meant that it needed Pluto to stabilize it. So that's why Neptune needed Pluto, and draw in Pluto from the Kuiper Belt. Pluto was never a planet. It was a big rock that had an orbit around the sun from the Kuiper Belt, and it was drawn in. I'll see you on the other side.